This is the first example in 3.4, and I'm going to do this problem building a revenue function. So when I read this problem, it says the price P, it should be price. Okay, so the price P in dollar and the quantity X sold of a certain product obey the demand equation, and they gave me the price in terms of the quantity as an equation. Now the other important thing I have to remember is when I look at the X values, the minimum X value is 0 and the maximum is 600. So that is the domain of this price function. Okay, so I'm asked to build a revenue model. So from here, they gave you the formula. Revenue is equal to X times P. Even if this was not given to you, you know revenue is price times quantity. So if I take the price function and plug it into this revenue function, I will get R of X equals X times negative 1 over 6X plus 100. Clean it up and write the revenue function by distributing the X in. So I will get a 100X. And this is what they mean by the model of creating a model of a revenue function. Okay, now a few things to remember here. Look at the function. It's a quadratic function. A value is less than 1, and we talked about this before. The independent variable is X. In this case, it's the quantity, and the dependent variable is revenue. And if I graph this function, I'm going to have an upside down parabola. Okay, I can use my calculator to answer C, but then I can also use what you learned in the previous section to find what the vertex point is. Okay, so we'll come to B. In order to answer B, it's asking me what is the revenue if 200 units are sold. So if it's 200, R of 200 is negative 1 over 6, 200 squared plus 100 times 200. Put this in your calculator and give me the final answer. It would be equal to so many dollars. Okay. Okay, the next thing it's asking is what is the quantity X that maximizes revenue? So that's the first part of the question. What is the maximum revenue? So if I find the vertex, I will get the X value, so which will answer the first part of the question. And if I get the Y coordinate, I can find the maximum revenue. Now, what we did in the previous section, in order to find the vertex, we called it H and K in general. H equals negative B over 2A. And in this case, my A is negative 1 over 6, B is 100, and C is 0. So negative 1B over A would be negative 100 over 2 times negative 1 over 6. Simplify, find the value of it. Whatever the answer is, take that back into the function. So we'll figure this out first. So it's going to be 100 to okay, so if you want to write this, you can say negative 100 divided by 2, negative 2 over 6, or we can also call this as a negative 100 divided by negative 2 over 6, negative 100 times 6 over 2, right? So this would be negative, so the negatives will cancel out, and I will have So if you simplify this, h equals negative b over 2a, plug it in, and then the simplified version would be 300. So x is 300, which is the first answer. So when it's asking what is the quantity x that maximizes revenue, the answer is 300. Now in order to answer the second part of the question, what is the maximum revenue? I'm taking this 300 and finding what r of 300 is. So it's negative 1 over 6 times 300 squared plus 100 times 300. Putting that in your calculator, 300 squared plus 100 times 300. I'm getting the revenue is 150,000. Oh, 15,000. I'm sorry. This should be negative 1 over 6 here. So it's okay. Okay. So the last part of the problem is asking us to find what price should the company charge to maximize revenue. We know that in order for us to have the maximum revenue, the quantity that you need to sell is 300, right? The x value. So in order for you to find the price, if you take the value for x, which is 300, and plug it back into this function, times 300 plus 100, whatever the price you get, the price that they have to charge in order to get the maximum revenue, and that is $50. Okay, I hope you all understood. If you have questions, please ask.